Okay, welcome back, everybody. Now we're doing 14.3 homework assignments, section 3 of chapter 14. Right. The first one is asking us to find the partial derivative of f with respect to x and then the partial with f with respect to y for the following function. So the function of x, the partial of x. So what we could multiply those together, or we can do the product rule. So if we do the product rule, we have x to the fourth minus 1, y plus 3. The derivative of this one with respect to x is 4x to the third. Derivative of that one with respect to is 0. That's for x. Same thing for y. We have 4x minus 1, y plus 3. Derivative with respect to y of that is 0. Derivative of that one is 1. Since it's a product for the x, we have 4x cubed times x plus 3 plus 0. Those are 0. So we have 4x cubed y plus 3. That's the first one. Now with respect to y plus 3 times 0 is 0, plus x to the fourth minus 1 times 1, which is x to the fourth minus 1. All right, now the number 2. Find the partials of x and y with respect to fx, x, y. This is the chain rule. So for x, derivative of the outside, which is 2 xy minus 5 times the derivative of the inside. That's a constant, so we just have y. So we just have 2y xy minus 5. And with respect to y, again, take the derivative of the outside, which is 2, leave the inside alone, subtract 1 from the x outside, times the derivative of the inside, which is just x. So it's 2y xy minus 5 to x xy minus 5. Number 3, find the partials of x and y. Now we have a quotient rule. So this is with respect to x, this is with respect to y. So the derivative of 8 is 0. The derivative of this with respect to x is 1. The derivative of 8 is 0. The derivative with respect to y is 2. So the partial with respect to x, this times 0 is 0, minus 8 times 1, all over the denominator squared. So it's negative 8x plus 2y squared. Do the same thing here. Partial of f with respect to y. That times that is 0. 8 times 2 is 16. All over the bottom squared. So that one's going to be negative 16 over the denominator. Number 4, find the partial with respect to this one. Okay, this one's going to take some thinking because remember, the derivative of e is just the exponent times e. With respect to x, the derivative of the top with respect to x is 1 times e x y plus 10. So it's e x plus y plus 10. Now with respect to y, the derivative of y is 1 times e x plus y plus 10. So it's the same thing pretty much. The function ln 4x plus 3y, partials of each. The derivative of ln is 1 over the operation times the derivative of the inside. So with respect to x, the derivative of the inside is 4. So it's 4 over 4x plus 3y. With respect to y, the derivative of the inside is 3. So it's 1 over 4x plus 3y times 3, which is 3 over 4x plus 3y. Right, so those are the first ones. Now number 6. Find the partials of this one. With respect to x, this is the product rule. So we have e to the xy times ln 5y. With respect to x, the derivative of this one is y e to the xy. And that's a constant, so it's 0. Which is e to the xy times ln 5y plus 0. So it's just e to the xy ln 5y. No, it's a y in front. I'm sorry. There's a y in front. Now with respect to y, I have e to the xy ln 5y. The derivative of this one is x e to the xy, because the derivative of y is just 1. It's an ln, so it's 1 over 5y times the derivative of the inside, which is 5, which is just 1 over y. So it becomes x e xy ln 5y plus e to the xy over y. Ln 5y plus e to the xy over y. Number 7. Find the partials with respect to each, with respect to the integral of g with respect to t's but now we got to find the partial. The partial of g of t is, well, this is g of y minus g of x. The partial with respect to x of this is negative x, and the partial with respect to y is g of y, because the x disappears. So basically, the derivative of the integral is just the letter itself. Since we're doing it to x, we're only taking the x value. Number 8. The function below models the work done by the heart's main pumping chamber, the left ventricle. Find the partial derivative with respect to each of the variables. So this function with respect to p, that's a constant, it disappears. So it's just v. With respect to v. Okay, so since there's a v, so it's p for this first part. And there's a v there, so the derivative of v is 1, so it's 6v squared over 2g. Or, I'm sorry, it's a delta, I'm sorry. With respect to delta, that doesn't have, it's a constant, so it disappears. So with respect to delta, it's, no, the delta's gone, so we have big V, v squared over 2g. But it's v times delta times v squared over 2g. It's not delta v squared, so no. With respect to little v, that one disappears. So this one becomes 2v, so it's 2v delta little v over 2g. The 2's cancel, so it's v delta v over g. And with respect to g, that one disappears. The g comes up. The derivative of that one makes it negative, and it goes back on the bottom as squared. So it makes the function negative. And brings the g back down as a square. Number 9, do the same thing. Find this. Now we got to find the second derivative of the following functions. So now when we find second derivative, we take it with respect to either xx, yy, xy, or yx. Each one of those have its own derivatives. So the first one, we'll do x twice. The derivative with respect to x is 7 ey. That's the first derivative. Here's the second. Derivative with respect to x is 0. All right, the next one. With respect to yy. This is take respect to yy. So the first, we have y here. Derivative of that would make it 7x e to the y plus 8. Derivative of y is gone. Now the second derivative, 7x e to the y, the 8's gone. So it's 7x e to the y. Now yx. What this one's saying here, remember, you have to read inside out. So the first one we have to do here is find the derivative with respect to x first. So that becomes 7ey. Now the second derivative with respect to y, which is 7ey. Now this one we have to do derivative of y first. So the derivative of y gives us this. Then we take it with respect to x. So we have 7ey. X goes away. So remember that during the lecture part, we said that it's commutative. If you take yx or xy, it'll give you the same answer. Sure enough, there's a proof of it. Okay. Number 10. Let's see what this one gives us. Now we got to verify this. That the second with this, which pretty much what we just talked about. So the second with y first, then x, and x first, then y. So here's our function. We're going to do y, then x. And then this one here will do x, yx. So the first one, let's take this derivative with respect to y. So we have 3x to the fourth times 6y to the fifth minus 5x to the third, 5y to the fourth. That makes it 18x to the fourth, y to the fifth, 25x to the third, y to the fourth. That was with y. Now we take it with respect to x. 18 times 4, 72, x to the third, y to the fifth. 3 times 25 is 75, x squared, y fourth. So there's the first one. 72 x cubed y fifth minus 75 x squared y fourth. Now do the same thing here with respect to y first and then x. With respect to y first, we have 18 x to the fourth, y to the fifth, minus 30 x to the third, y to the fifth. Now with respect to ooh, crap. I did the y first. Let's just do x first. So it's 12 x to the third, y to the sixth, 15 x squared, y6. Now with respect to y. This is with respect to x, this is respect to y. It's 12 times 6, 72, x3, y5. 6 times 15, No, it's 5. So 5 times 15 is 75 x squared y to the 4th. And sure enough, you see they're exactly the same. 72 x cubed y 5th, 75 x squared y 4th. Does it? Yes. Well, actually, I put that down. All right. Now number 11. With this one, we have to use a little bit of trigonometry because we're given this obtuse angle, a triangle, and we want to express A implicitly as a function of A, B, and C. And then we're going to calculate partial of A with respect to A and B. So because we're trying to find this A, we have to use this formula. So first off, we take it with respect to A. So we have 2A, that's constant. Now this, since it has A here, we have a product. Negative 2BC cosine A. Derivative with respect to A is 0. Cosine is negative sine A dA dA. So it's, since it's a product we add, negative is it's a positive. So it's two BC sine A dA dA. Divide both sides by this. Those cancel. So dA dA is equal to, those cancel, A over BC sine A. That is the first one. To find TB, since we're still looking at A, we have to use the same formula. But this time, this is for the first one, this is for the second one. Now we look for it with respect to B. We're trying to find partial of A with respect to partial of B. So with respect to B, this one goes to 0, 2B, 0. So we have 2BC cosine A. The derivative of with respect to B is 2C is negative sine A dA dB. So that's 2C cosine A minus 2bc sine A dA dB. To b, distribute that negative sign through there, so we have minus 2c cosine A plus 2bc sine A partial of A partial of B. We're solving for this. So we're going to move both of these over first. So we have minus 2b plus 2c cosine A equals 2bc sine A dA dB. Then we divide both sides by 2bc sine A. The 2's cancel. So we have negative b plus c cosine A over bc sine A equals the partial of A over the partial of B. And that is the second answer. All right, I hope that helped. Good luck, everybody.